try to tape it all at once for you, okay? All right. So the whole point here is, can you look at a graph and tell me in the general vicinity if it's a min or a max? Yeah. Okay. So whenever you're talking about local mins or maxes, is it, when I'm talking about the local min or max, what kind of value is it, X or Y? It's a Y value. The value, when you're talking about the value, it's a Y value. So the relative min or max is, its Y value is how much, and its X value is where it occurs. And this is how much. Or when. More importantly, actually it is, most of the time it is when. You're actually correct, because most graphs, when we do something when we graph something like this, we want to know, it's, in reality, what do we want? We want to know how things are changing with time. Got it? So the relative min or max is, the Y is how much it is. How high is it? How low is it? And the X is where or when. Okay, so look at our graph really fast. Looking at this graph, does it go on forever and ever and ever in each direction? So if that's the case, is it continuous everywhere? Because that's the first thing you have to do before you do domain and range. Is it continuous, or is there an issue right here? What is that? We have a hole. Remember holes from Algebra 2? Yeah. It's where you had a factor you removed. Yeah, well, you have it because you had some amazing Algebra 2 teacher. He had me. I did? Oh. Yeah, he did. Smart. I'll get even with you, don't worry. A hole is where you factor out the same factor from top and bottom. You removed your problem. It's removable discontinuity. Okay, other than that, is it continuous? So do we have to write the domain for all x's except for that one? How do we write that? So what's it coming from? What's this? That's negative infinity, right? Well, how do we write the whole? What value is that at? -1, open parentheses, meaning don't include the point. Yes, you knew that. And then what about the rest of it? -1 to what? Infinity and beyond. Okay, looking at the range. Are all y values possible? No. Let's look at this. Let's look at this. Is this a horizontal? This is a horizontal asymptote. Okay, so does it go down to negative infinity? No. It goes to 3. What's the lowest point there is? Whatever this is, what is it? Okay, the lowest it can go is -4. And what's the highest it can go to? So is it going to be -4 to infinity? Now I didn't put the parentheses. This one's going to be an open. What about this? Can it get to -4? Yeah, so do we do a closed bracket? Y'all understand how to do that? X-intercepts. They're not pretty, are they? No, but can you guesstimate them? So if we zoom in here, can you give me an estimate of what that value is? Is it past -4.5? Can we call it -4.6? Okay, so if we're writing the x-intercept for that, it's -4.6, and what's the y-coordinate? 0. Okay, what is this one? Just a little bit past 9. How about -9.4? About the same amount, right? 0. Does that make sense? Sorry, no, can't see that. That makes sense now. I was blowing it up so that y'all could see the... There we go. What about the y-intercept? Can you read that? Is that a nice number? Oh, yes, it is. It's this point right here. What is it? Okay. Thank you. Ooh, good job. Nice recovery. 0.5. Next thing you're going to have to do on these. What does this mean when you do this function notation like that? F parentheses -4. What does that mean? Is this the x value? Does that mean go look on the graph and read off the graph? At -4, what is the y value? Because f of x is the y value. This means y. So you want the y at -4. What's the y at -4?
3.
Okay.
0?
No, it's 3.
Oh, okay.
It's 3. Okay, what about at -1? Is there a problem?
3.